Welcome guys, let's solve another LeetCode daily challenge. Insert, delete, GetRandom. 01. Implement the randomized set class. Randomized set initializes randomized set object. Boolean insert into well inserts an item well into the set if not present. Returns true if the item was not present, false otherwise. Boolean remove into well removes an item from the set if present. Returns true if the item was present, false otherwise. Int GetRandom returns a random element from the current set of elements. It's guaranteed that at least one element exists when this method is called. Each element must have the same probability of being returned. You must implement the functions of the class such that each function works in average time complexity. Well, this challenge is pretty interesting because unlike other challenges that we did previously, this challenge requires implementing and designing the whole data structure with its set of functions. They are insert, remove, and GetRandom. Let's discuss this challenge. There are three methods that we need to implement: insert, remove, and GetRandom. Well, the most important part of this challenge is that all these functions must work for O1. It means for constant time. And to implement to solve this challenge, we need to think about the collections that we can use to solve this. Well, among all the collections, let's talk about the ones that provide insertion and removal for constant time. I can the first data structure that comes to my mind is the hash set. I mean, we can use the hash set because it can insert and remove an element for constant time, thanks to hashing concept. I can use the hash map for insertion and removing. Well, but there is a problem for the third function, for the third method for GetRandom, because hash map doesn't provide any function that can return a random element, because the hash map works on the with the keys, because we provide some key. The hash map hashes the key and transforms into some hash value based on which it returns some element. But here this function doesn't accept any argument. That's why it returns a random element from the hash from the set. That's why a hash map is not enough for this function. Let's talk about other collections that provide an access for constant time. Accessing for constant time, I can think about arrays, because arrays, if you know any index, you can access any element for constant time. That's why I'm going to use arrays here, or arrays or lists, it doesn't matter, and that's why I'm going to use here arrays. Well, if we combine these two functions and implement this, we can implement all these functions satisfying this requirement for that our functions will work for constant time. Let's consider one example right here. We have a set of values that will insert and remove. Well, let's take 5, 8, 10, 7, and 3. Well, I want to insert all these values, and then once I want to remove one element, and then I want to call in the GetRandom function. Well, let's begin. Let's say that we have applied the insertion function, and after calling insert function, on all these elements, we'll get the following map. We'll construct the following map. We'll get the map where the key will be the element and the value will be index. The index for 5 will be 0, 5 and 0. For 8, with the next value 8, we'll have index 1. They will be, and 10 will have index 2, and 7 will have index 3, and 3 will have index of 4. Well, this will be our map, and we are storing here an array. Array will store all these values as well, because we'll need array for getting random element for a constant time. It will just duplicate all these values: 5, 8, 10, 7, and 3. I'm sorry for my handwriting, for awful handwriting. Well, see, the challenging part here is that when we delete some value, I mean, when we remove some value, okay, let's say that we are going to remove the element 10. Let's see what happens next after removing 10. We instantly get this value. This value 10 has index 2 indicating this value from the array. Well, we need to remove this one and this one as well. When we remove this value from the array, there will be empty space. When there is an empty space in the middle of the array, all the values standing after this, 7 and 3, will need to take up this space. It will cause this, all the values standing right from this value will take the space. I mean, all these values will move to right, to left. And when these elements move left, it will take on time, and this is not unacceptable because the removal function needs to work for constant time. It should work for one time, and we need to think of another way to achieve this. Of course, there is a way to do so. Instead of removing right here, I want to do the following. I want to swap. I want to take this value from the last value. I want to swap these values, and here will be 3, and here will be 10. And then I can remove the last item, because if we remove the last item from the array, it will work for 01, because there are no elements standing right here that needs to be moved here. That's why removing the last item will work for constant time. That's great for our case, but here we need to change as well, because this value from the map has index 4 indicating 4, but after removing this value, there is no value at index 4. That's why we need to update this one as well. After swapping and removing this value, value of 3 has index of 2, and that's why this needs to be updated as well. After doing so, after implementing this approach, our remove function will work for constant time. That's great. And GetRandom function will work for constant time, because we have a ready array and we can access any element for one time. That's great. Let's jump into coding this challenge and submit the solution later. Well, first of all, I need to initialize the hash map for this challenge. I'll call it random map. This will be a mutable map of int, and I'll need array. This will be a mutable list. Mutable list of int. Well, if random map already has this value, if it's not null, I'm going to return false because it's already present. Return true. Random map well is equal to array size, and here I'm adding this value as well. Let's make it private, this one as well, and that's it. This is for inserting, and the same, let's implement the removal method. First of all, we need to check if there's if this value is present in this map, in the set. Random map well, if it is a null, just return false, and this will return index of this value. Here we are removing 10, it will return index 2. This indicates the index in the array. After that, we need to do the following. Here we need to swap these two values. Well, let's do the following. Array last value, and the values array index will be last value, and array after swapping we can remove the last element. And next we need to update last value. Last value will be index, and random map remove well, return true. And here by that time we already have the ready array where on which we can call the random function. That's it. I hope this is everything I needed to implement, right? Let's copy and submit the solution. Well, let's submit. I think it will work. I hope so. That's great. Our solution was accepted and the algorithm was pretty efficient. The runtime beats 80% of users and the memory beats 99% of users. That's great. And speaking about the complexity, the runtime will be 1 because everything is working based on hashing, and the memory is on. Space is needed to store all the variables. This is time complexity, this is runtime. That's it. This is the end of this tutorial. I hope you learned something new. If it was useful, please like and subscribe, and see you in the next videos.